So this exercise is related to electric field and capacitors MCQs. As you can see in the first question, these are the equipotential surfaces. So the diagram shows equipotential lines or equipotential surfaces are there. Near the charge, near the source, the field lines are closer. The equipotential surfaces you can see are closer. Why? It means like there will be greater force. So we can move a charge to a small distance to do like work done from one equipotential surface to another equipotential surface is same. So if you do a work done, if the work done is 2 joule per coulomb or 2 joules here, the same work done 2 joule. But because this part is near the charge, so force is more. That's why a shorter distance between the equipotential. This is away from the charge, so weaker force. As a result, we can move the charge to a greater distance. So the question is, which of the following diagram shows a possible combination of electric field lines and the polarity of a charge to produce this pattern? So how we can work out first about the polarity? Look, remember, like the potential always decreases if we move from positive terminal to negative terminal. Positive terminal is always at high volts and negative terminal is low volts. So if I say this is the positive terminal and this one is a negative terminal, and the potential across between them is 200. So what does it mean? Here it will be 200, then in the center 100, and near the negative it will be 0. So because the potential is decreasing, then what should be the charge here? It means this should be a positive charge, because when we move away from the positive charge, the potential or the voltage, the electric potential or a voltage decreases. If it was a negative charge, then it should be other way around. Like here we will have 0, then number will be there, but it should increase if it was a negative. So it must be a positive charge. Then what about the electric field lines? If this is a positive charge, so for a positive charge, electric field lines must point outward. So the radial field lines, electric field lines should point outward. That's why option A will be the right answer. Is it clear, this one? Question 1, MCQ. In question 2, the diagram shows a potential which is applied across the two. So which is a positive plate, top or bottom? Which is a positive plate here? This is high voltage, this is 0 volts. So top plate is a positive plate and bottom plate is a negative plate. The point X is a midway between the plate, like halfway between the plate. Which of the following is the electric field strength at point X? Remember, the electric field strength at a certain between the two parallel plates is constant. Like the electric field is constant between the two parallel plates. So we have the formula B is equals to ED, or E is equals to V divided by D. So strength of electric field between the parallel plate is given by voltage, potential difference 10, and but this is in centimeter, we have to convert it to meter, so it will be 20 to 10 power minus 2. So when we simplify this, as they're asking for the strength, so it will be 10 divided by 20 to 10 power minus 2. So when we solve the strength of the electric field, we get the value that is equals to 50. So either option A can be a right or B. And then what about the direction? What is the direction of the field lines? it is always from positive to negative. So what will the direction of these field lines? From positive terminal to the negative terminal. So it is, in this case, it is downward. That's why option B is the right answer. In question 3, point charges are there, like two small charges are there. One is plus Q, another one is minus Q. Are placed at X and Y respectively. As you can see, X and Y. When another charge is placed at Z, the resulting force on the charge X is 0. The distance XY and the distance YZ are same. Which of the following is the charge placed at Z? So how we can work out what is the charge placed on the Z so that the resulting force should be 0. So as in the beginning, we have a point charges. One is a point charge plus Q, another one is minus Q. And they are placed between X and Y. And there is another charge placed here, like it is another charge. And the resulting force on the charge at X is 0. So the resultant, there is a force, but the resultant force is 0. So first, if we work out, like this is plus and minus, so what is the direction of the force? The direction of the force on X due to Y is in this direction. Now, we want the resulting force to be 0. How? If we want the resulting force to be 0, it means there should be a charge, a positive charge must be placed here. Because and between these two positive charges, what should be we need the force F, but that is point outward. So between X and Y, what will be the force between X and Y? How we will work out? If we say this distance is R, between X and Y is R, and between X and Z, because they mentioned X and Y and Z are same, so between X and Z that will be 2R. But we want the force to be same. We don't want to change the force, so that Y is the charge at Y is pulling the charge at Q at X, and the charge at Z is pushing the charge at X. So X and Y, the force between them is given by formula F is equals to K Q1 Q2 or Q plus Q and minus Q over R square, where R is the distance between them. Now, when we check the force between X and Z, we want the force to be F. So, and the distance become 2R. If the distance become 2R, what is the relation between force and the distance? It follow inverse square law. Means if the distance become twice, if a distance increase by 2, the force should decrease by 2. So if the force decrease by 2, if distance increase by 2, the force should decrease by 4 because it vary with a square. So if the force is decreasing by 4 due to increase in distance, we want to increase the charge. So what should be the charge here? If one of the charge is Q, the other charge should be 4Q. So that because the force between them directly proportional to product of the charge. So we want if we want the force to be same, due to change in distance, the force is decreased by 4. So due to change in the charge, the force should increase by 4. And how a force can be increased by 4? If the charge is multiplied by 4. That's why the charge on Z should be 4Q. Is it clear? That how we can create, because we want to create a resultant force 0, on charge X, it means we want the same force but in opposite direction. As the distance between X and Z is double, the force will decrease by 4. So how to balance that decrease in force? So we should increase the charge by 4 times. Is it clear, this part? The variation in the force and the distance? Or simply you can also understand, we want the force F here. Both cases, like we want the force F. Here the distances are, but here the distance is twice. So if the distance, it is inverse square, so if the distance is double, the force will decrease by 4. So what we want the force to be same. So how force can be same? Force must increase by 4. The change in the charge should increase the force by 4. So how the charge, product of the charge should change? Should it increase by factor 4? Because if the product of charge increase by 4, the force will also increase by 4. So the total force will be same. Due to change in charge, it is multiplied by 4. And due to change in distance, it divided by 4. So it should be D as the right answer. Which of the following unit is equivalent to Farad? So Farad is a unit of capacitance, and we have the formula Q is equals to CV. So C is equals to Q divided by V, where Q is the coulomb charge and V is the voltage, or CV inverse will be the capacitance. So B will be the right answer. In question 5, a potential V is applied across two identical capacitors of capacitance C in series. Which of the following expression is the total energy stored in the capacitors? So we have two capacitors which are connected, identical capacitors are there, each is having a capacitance of C. And we connect with a supply, the voltage is V. Now, because they are connected in series, the total voltage, as they are identical capacitors, the total voltage will divide. Here it will be V by 2, here also V by 2. And the formula which we can use to get the energy stored in each capacitor, there are three formulas. One of the formula, energy stored is half Q into V. That is one. But this is only valid if we know the charge and the voltage. Another formula, energy stored is half CV square. This is valid if we know the capacitance and voltage. And here we know the capacitance and voltage. And the third formula is half Q square over V, but this is Q square over C. But that is valid if we know the charge and capacitance. But we know the voltage and capacitance. So we'll find the energy stored here, substituting it in the formula. That energy stored by the capacitor is given by half CV square. So it will be half C is the capacitance and V is the voltage. It will be V by 2 whole square. So this, when we simplify this, it will be half CV square over 4. When we multiply, it will be CV square divided by 8. But that is the energy in one capacitor. And same way as the energy stored in the second capacitor, half CV square. So energy stored will be half C is the capacitance and V is the voltage, which is V divided by 2. When we simplify, it will be half CV square up by 4. And when we multiply, it will be half 1 by 8 or CV square by 8. So, but what is, they did not ask energy each, they asked for total energy. So we have to sum them. We have to add, like if I add CV square by 8 plus CV square by 8. So when we sum, it will be CV square by 4. As 8 will be the LCM, so it will be CV square by 4, or I can say 1 by 4 CV square. So the answer option A will be the right answer. Is it clear? Question 5 about the energy stored in the capacitor. In question 6, two parallel conducting plates are there which are at a distance d and the voltage is V and the charge is halfway. Which of the following give the magnitude of the force? So magnitude of the force E is equals to F divided by Q. Electric field strength is force per unit charge, or F is equals to E into Q. And what about E? V is equals to ED. So E is equals to V divided by D. So force will be equal to V divided by D into Q. The force will be equal to, because E is equals to V divided by D. So in place of E, if I write V divided by D, so VQ divided by D. So it matches with option D. So this is a formula for relate electric field strength and force, and this is a formula which relate voltage, electric field strength, and distance for parallel plate. When we simplify, in place of E, we write V over D, and Q is there, so it will be VQ divided by D. That's the force experienced by the charge which is placed in between the two parallel plates. The potential difference across the capacitor is V naught. The capacitor discharged through a fixed resistor and a time equal to a time constant. Which of the following expression is correct? So time is equals to time constant. Like we have the formula V is equals to V naught e raised to power minus T over RC. So when time, like this, small t is equals to time constant or RC. So we can say V is equals to V naught e raised to power minus RC over RC. So when we simplify, V is equals to V naught e raised to power minus 1. And e raised to power minus 1 will go there in denominator. So V is equals to V naught divided by E. So the voltage which is there in the capacitor after a time equal to the time constant is V naught divided by E. So V naught divided by E, that's why option B is the right answer. In question 7, which of the following is used to discharge, the following circuit is used to charge a capacitor? Which of the graph shows a variation of a current? Current always decrease, even it is a charging or discharging, the current always decrease. So option C and D cannot be an answer. And when the capacitor is charging, the charge, because it is for charging of a capacitor, so the charge on the capacitor will increase. So discharging and charging currents are same, but this is a charge stored increase, and if the capacitor is discharging, the charge will decrease on the capacitor. So in this case, B is the right answer. And in question 9, which of the following is a unit of the permittivity of free space? So according to Coulomb's law, F is equals to K Q1 Q2 over R square, where K is equals to 1 upon 4 pi epsilon. So Q1 Q2 over R square. If I need epsilon, so epsilon is equals to Q1 Q2 over 4 pi F and R square. Q1 and Q2 are the Coulomb, so Coulomb multiplied by Coulomb. 4 and pi are the constant. F is a force Newton and R is a distance meter square. So Coulomb square Newton per meter square, or Coulomb square Newton minus 1 meter minus 2, or order can be changed. So Coulomb square Newton minus 1 meter minus 2. So B will be the right answer. And the question 10, two charge spheres which are having an equal mass and with an insulating thread equal length. One sphere is having a charge Q, another one is 10Q. Look, if they have the equal mass, and according to Coulomb's law, if a 10 Newton force is applied on charge 1, the same 10 Newton force will be applied on charge 2. Like if two charges are placed, they might be identical, they might be different. Like this is 3 Coulomb, this is 7 Coulomb. So when they are applying, say, a resultant force is 100 Newton. So if 100 Newton on this charge, same 100 Newton on other charge. And as they mentioned, both have the same masses. So if the mass is same, F is equals to ma, so both will have the same acceleration, or both will displace equal distance from their mean position. So option C will be the right answer, because they both experience the same force and they have the same mass. So they will have the same acceleration or same change from the original position. That's why option C is the right answer. So these are the MCQs, first 10 MCQs, but there are about like 30 MCQs remaining you will solve from electric field and capacitor. Next session, we will do the structure questions from this topic.